Hello everyone, welcome again in Eng-Man YouTube channel. So we will continue our learning on retrograde condensate modeling using PVTP software. It's a very powerful and interesting software for fluid modeling. All right, now we reach a point where we will perform primary regression. We will perform the initial regression on the liquid density, saturation pressure, and separator density, as well as the GOR, which will act as the anchor point using critical temperature, critical pressure, binary interaction coefficient, and also the volume shift of the pseudo component. All right, so first we highlight this PVT fluid or PVT sample, and then double click here on the add regression. Okay, so you highlight this and then add regression. Okay, so now we will have a new object called regression. So it will regress the PVT fluid here, the object before the regression. And the output fluid will be stored here, PVT fluid 1. Okay, maybe I can rename this, edit label, and PVT reg 1. So the fluid model after the first regression. All right, so you will have something like this. So PVT sample and then pseudo properties, the output fluid for the pseudo properties, and I call this PVT fluid or maybe pseudo. Okay, and then after that regression and then PVT reg 1. All right, so now let's double click on the regression here. Okay, so we have here 4 experiments. The first thing is saturation pressure, constant volume, depletion, and then constant composition expansion, and the separator. And for the regression window, we have lab data weightings, regression inputs, regression variables, and later the error details, as well as the output fluid. Okay, now first we focus on the lab data weighting tabs. Okay, this is where any data points that we do not want to be included in the regression can be excluded, and other data points can be set with specific weightings. The idea being that selecting fewer data points to match to will give the regression algorithm flexibility and additional degrees of freedom to achieve a good match. Okay, and as the experimental data has already been added to the PVT sample object, all of the data is automatically populated into the regression. So that's why we have 4 experimental data here. Now we will take each experiment in turn. We start with the saturation pressure. All right. As the saturation pressure is, of course, something that we will want to match to, this data will be left included. Okay, so you can do something like this. And then if you exclude, you highlight them and then press exclude. But of course, we want to include them. So highlight them, include something like this. And the weighting that we want to give to this data is, of course, high. And the value is 10. And then it should be noted that obtaining accurate measurement at the 2 point, especially for near critical fluid, is difficult, as the liquid and vapor phase become hard to differentiate. To avoid these uncertainties, you may wish to instead regress on the fluid density near rather than exactly at saturation pressure, if available. Okay, and then we continue with the constant composition expansion. All right. Okay, so select the constant composition expansion from the laboratory experiment list. Here, the liquid dropout and the z-factor are of particular importance. For the relative volume, it is the slope of the curve rather than the absolute values that is of greater importance, since it is directly linked to the fluid compressibility. Any data we are unlikely to use in the regression, such as the relative volume or maybe erroneous data, can be excluded by selecting the relevant data points and then, as I said before, pressing the exclude button. Additionally, we may wish to exclude some data points to speed up the regression. All right. And the process of deciding which data points to exclude can be aided by plotting the entered data as a function of pressure and temperature to identify the outlier or unphysical behavior. This can be achieved by opening the PVT sample and regression objects side by side, like this. Once again, check the PVT sample, enter lab data, constant composition expansion, and then here, plot lab data. So like right now, we are plotting the liquid dropout. So if you find something unphysical, something weird, you can just neglect them or exclude them from the regression. Okay, so you put them side by side, first the sample on the left side and the regression window on the right side. The data can be plotted in the PVT sample object, like I did before, like this, and the respective data points included or excluded in the regression object, you can show it here. All right, and then for the CCE now, we will exclude all the liquid dropout points. Okay, so let's be careful here. We will exclude all liquid dropout points, not the liquid dropout at saturation pressure. Okay, we need to keep them as they are. Okay, so I'm going to exclude this. Highlight them, exclude. Okay, and then we also exclude the relative volume, all of them, to speed up the regression. And also because relative volume is not very important to, to get perfect match for the exact value. As I said before, the trend or the slope of the curve is much more important compared to the absolute value itself for the relative volume. And then let's go to Z factor. We will exclude the, let's say, here. Okay, so this is the Z factor. It's almost straight line, so actually we don't need to include all of them. To speed up the regression, we can exclude some of them. So I'm going to exclude the second, 2, 3, 4, 5, 6, 7. Exclude. And then 8, 9, 10 to 12. Exclude like this to speed up the regression. Okay, and then we go to the next, CVD. As we already have liquid dropout and vapor Z factor in the CCE, we do not also need to match to the CVD data. So let's go to CVD first, liquid dropout like this. So I'm going to exclude for the CVD all liquid dropout points. Exclude. Again, because I already have liquid dropout data in CCE. And also all vapor Z factor points. Okay, it doesn't mean that I disregard the CVD, no. But I just do not use them for my regression. Later on, of course, after we regress, of course, we still need to check the quality for the matching for the CVD. Okay, we just do not include them for the regression process to speed up the regression. Okay, for this first regression. Okay, and now lastly, the separator. The GOR from the first separator stage and the liquid density at standard conditions are of particular importance here. The reason for this being that on the first separator stage, most of the gas is evolved. And because it is the easiest to obtain an accurate oil sample at standard conditions. By the time you get to the regression stage, the equation of state should already be somewhat reproducing the first stage GOR and liquid phase density at standard conditions, and thus do not require, more significant tuning. Nonetheless, they are included in the regression here as they will act as an anchor point, which prevents the equation of state from drifting too far from the former. However, we want them to have a small impact on the error function, or otherwise the regression would be too constrained and thus unable to match the other parameters. Again, this is very important. At this stage, we need already to have a good or relatively good match for the first stage GOR and liquid phase density for the oil. If indeed you have, and of course, right now we have relatively good match for the GOR and the density, we can use these two values as anchor point. Why do we need the anchor point? This anchor point will protect or will guide the first regression stage such that the resulting fluid, the resulting model after the regression will not deviate too far from our current state. I can say that the current state is relatively satisfactory because we have good GOR and a good oil density. So we use them as anchor point so that the regression for the saturation pressure, constant volume, depletion, and constant composition expansion will not deviate too far from this point. But of course, we do not want to include everything in the separator test. So that's why I will exclude the second stage GOR. And then for the liquid oil density at standard condition, although we want to use them as anchor point, but we give them, in this case, weighting of 7. Indeed, they are the anchor points, but we do not want the regression to be too constrained by these two anchor points. So that's why we give more relaxed weighting. I give them 7. And for the first stage GOR, I give it 5. Okay, and it will be colored purple like this or light blue. Okay, and once done, we go to the regression input